Welcome to our quiz review solutions for sections 1.5 and 1.6. The main topics that we're going to look at today are function arithmetic and difference quotient from section 1.5, as well as finding the domain of our new functions that we create. And then in section 1.6, what we are doing is reviewing like graph analysis. So I'm just going over a couple of the problems, the more difficult ones, and going through them step by step for you. So on page 84, I've chosen to do numbers 7 and 14. So we'll start with number 7. We're given f of x and g of x here, and we have to do 6 different things with it. So I'm going to do a couple of those things. The first one I'm going to do is f plus g of 2. There's 2 different ways to do this. What you can do is first add f and g together using like just x and get a new polynomial, or you can just plug 2 into each one and then add them together. It's really up to you. So I'm going to do it that first way. So the first thing I'm going to do is find f plus g of x and add them together. So I'll have 2x plus 1 over 2x plus 1. Can't really do too much more there, so I'm going to plug in 2. When I plug in 2, I'm going to get 2 times 2 here, which is 4. And then down here, when I plug in 2, I'll get 4 plus 1, so 1/5. And so this is 4 1/5, or 4.2. Or you can write it as an improper fraction. So we'll multiply and get 20 plus 1, so 21/5. Those are all fine ways to write your final answer. Okay, I'm going to skip the second thing, but I am going to go into doing g minus f of 1. And so I'm going to do this in another way. I'm going to actually do g of 1 minus f of 1. I can actually do it this way and plug in first and then subtract. So if we find g of 1, that means plugging in 1 over here. So that's 1 over 2 plus 1, so 1 over 3, or 1/3. And then f of 1 is plugging in 1 here, which is 2. So I'm going to do this subtraction here. This is 1/3, and then I want to get a common denominator, so that is 6/3, which gives us negative 5/3. Okay, the next one I'm going to do is f times g of 1/2, so I can find the function fg, or I can just plug in 1/2 to each one, which I think might be a little bit easier for these ones that aren't addition. So f of 1/2 will give us 1. And then g of 1/2, this down here, 2 times 1/2 is 1, plus 1 is 2, so this is 1/2. So this ends up being 1 times 1/2, which is 1/2. And the last one that I'll choose to do is g over f of negative 2. All right, g over f. Now what I'm going to actually do first here is talk about something a lot of us missed. So I'm actually going to do the function with x, not negative 2 first, just to kind of prove a little point here. All right, let's write out what this function is. I'm going to put the g on top, which is 1 over 2x plus 1 all over 2x. And I'm going to put this as 2x over 1. When we have a complex fraction like this, when we're dividing fractions, we flip the second fraction and multiply it. So this is really 1 over 2x plus 1 times 1 over 2x, which is 1 over 2x plus 1 times 2x. They end up actually both being in the denominator. So if we look and see what values can we not plug in, whatever makes this guy 0 and whatever makes this guy 0. Well, what makes 2x 0 is 0, so we can't plug in a 0. And what makes 2x plus 1 0, we can do that real quick off to the side to see what makes it 0. And that is the value negative 1/2. So that means x can't be negative 1/2, and x also can't be 0. So these are 2 numbers that we can't plug into this function here. They're not in our domain. So I'm just going to look at that off to the side there. Okay, what we were asked to find was g over f of -2. I can plug in -2. That's not one of our restricted values. So when we plug in -2, we'll have 2 times -2, or -4, plus 1. So that gives us -3. And then over here, we'll have 2 times -2, which is -4. So in our denominator, we'll have positive 12, so 1/12. In number 14, we're asked to add, subtract, multiply, and then divide f and then g, and then find their domain. So I'm not going to do the addition one, but I will look at the subtraction, multiplication, and division. Those are the ones that we made the most errors on. So doing f minus g of x, we do need to make sure that when we subtract, we're careful. Now in this case, what we're subtracting only has one term. We're subtracting 7x. But if that had more than one term, we definitely would need parentheses. It does only have one term in this case, so we're just subtracting the 7x. So I don't technically need the parentheses, but just be aware that if you're subtracting more than one term, you definitely do need parentheses. All right, so we have x squared minus x minus 7x, which is x squared minus 8x. And that's fine. We can just write it like this. We don't have to do any sort of factoring. What is our domain? It's all real numbers because there's no x's in a denominator or under a square root that would give us any restrictions on the domain. Okay, next we're multiplying. And when we multiply, we just have to be careful with distribution. So we're first going to multiply x squared by the 7x. When we do that, we'll get 7x cubed. Then we're going to multiply this minus x by the 7x, which is minus 7x squared. And this, again, this is a totally fine way to write your final answer. If you are asked to factor, we can factor out the GCF of 7x squared, and then we'll be left with x minus 1. So these are two different ways of writing the answer, but this one is in standard form, and this one is in factored form. Now, what is the domain? Once more, it is all real numbers. There's no x's in a denominator or under a square root. Okay, lastly, I'm going to do division. And division is just a fraction, so we'll write in our numerator x squared minus x all over 7x. Now, we can simplify this, but before we do that, I want to look at what the domain is. If we look at our denominator, we see that we have an x in it, so we do have a potential restriction on our domain, meaning I cannot let this denominator be 0. What value of x, if I plugged it in, would make this denominator 0? 7 times what is 0? Well, 0. If you think about that a little bit off to the side, we think 7 times what gives us 0. If we divide both sides by 7, x is 0. That value will give us a 0 in our denominator. Therefore, we have to restrict 0 from the domain. So we can include all values of x except 0. So that's how we exclude 0 from the domain. Now, if we kept simplifying, I'll do that in blue, we can factor the numerator. The GCF is x, and when we take the x out, we're left with x minus 1, and then we still have 7x in the denominator. Now, these x's are both factored out. They are not being added or subtracted with anything. Whoops. And this x can cancel. And when that happens, we're left with x minus 1 over 7. So that is how we can write the final answer, but again, we had to figure out the domain before we canceled because there's still an x there from the original problem. This is just a simplified way of expressing it. So we'll write it like this, but the domain we have to find before we do any factoring or canceling. And the next review problem we'll look at is on same page, number 24. This is finding the f of x plus h, the difference quotient, right, minus f of x all over h. And we're going to do it with this function here. When we do that, when we plug in x plus h, we'll have 3x plus h squared minus x plus h. And we'll do that part. That was in blue. And we'll do this part in white. So minus the original function. Again, we need parentheses here. This was a mistake a few students made. All right, we do need those parentheses there because when we distribute, we do have to use that negative sign. All right, then we'll come down here. When I square the x plus h, I still have the 3 out front. When we square the x plus h, we end up getting x squared plus 2 xh's, right? Xh plus another xh plus h squared. Distribute the minus sign through to get minus x minus h. Then distribute this minus sign through to get minus 3x squared plus x, and then all over h. Now here I still did not distribute the 3 because I have to use PEMDAS, order of operations. Exponent first, then we multiply through by the 3. So when we multiply through by the 3, we'll have 3x squared plus 6xh plus 3h squared minus x minus h, no more color coding, minus 3x squared plus x all over h. Now everything without an h in it should cancel. So we'll cancel an orange here. We have a positive 3x squared and a negative 3x squared. We have a minus x and a plus x, and everything else has an h in it. So we have 6xh plus 3h squared minus h all over h. When we factor out the h in the numerator, we're left with 6x plus 3h minus 1 all over h, and then the h's cancel. So our final answer is the 6x plus 3h minus 1. Yes, kind of a weird idea, but again, it is a prerequisite for finding a derivative in calculus. Okay, moving on to section 1.6. This is all about the graphs and analyzing the graphs of functions. So we have our function here, a square root function, the square root of x minus 2. Now you can totally put this into your calculator and see what it looks like. A square root function is an arc, and in this case it's going to start at 2 and then arc like this. But let's think about what numbers we can and cannot plug in. Like, what's the smallest number we can plug in? Well, the smallest number that can be under a square root is 0, right? We can't take the square root of anything that's negative. So we can take the square root of 0 at 0. What would make this 0 in here? If we plugged in 2, then we'd have 2 minus 2. So if we plug in 2 for x, we'll have the square root of 0, which is 0. Then we can't plug in like 1. Right? I would be negative there if we plugged in 1 or anything less than 2. So we have to keep getting bigger. So I'll try 3. 3 minus 2 is 1. I can take the square root of 1. The square root of 1 is just 1. Now if we plugged in 4, we'd have 4 minus 2. We'd have the square root of 2. While we can get a decimal approximation for that, there's no need to really graph something like that. Let's plug in 5. That'll give us a square root of 3. But if we plug in 6, we'll get the square root of 4, which is 2. So let's just try those for now and see what that looks like. 2, 0, 3, 1, and 6, 2. If you kept going, you see that it arcs up slowly. So this is what this graph looks like. And it's what all square root graphs look like. All right, now we need to find the domain. We can just look at our graph visually and see that going from left to right, the smallest x value that we can be is 2. Then we can be any x value greater than 2. So our domain starts and includes 2, so closed bracket, and goes all the way to infinity. That's our domain. Now, how could we have found that algebraically and not graphically? We could take what's under the square root and force it to be either 0 or greater than 0. Because that's what it has to be algebraically. Then when we add 2 to both sides, we'll have the domain is x is greater than or equal to 2, which that's in interval notation, x is greater than or equal to 2. Let's find the intercepts. The intercepts are where we cross the x or y axis. It's where the opposite variable 0. I can already see that we hit the x-axis at 2, and that's when y is 0. So our x-intercept is 2. And then our y-intercept, where do we hit the y-axis? Never, right? We never hit it, so we don't have any. So we can graph by plotting points. You can use your calculator. We have to understand how to find the domain, and I think that's a lot easier to do graphically. Or you can do it algebraically, like I showed you. And then the intercepts are where we hit or cross the axes, and it's where the opposite variable is 0. Sometimes we don't have an intercept, like in this problem. Okay, the last problem that we'll do together today is graphing a piecewise function. So piecewise is just like graphing a regular function, but in only certain parts of the graph. So I'm going to move left to right. So starting at negative infinity all the way up to -2, right? We have the graph of x squared, which as we know just is a nice parabola with a vertex down at the origin. But I'm going to plug in some points, and or I could have written f of x here. All right, so I can plug in -2 because I can plug in -2 in anything less than that for this function up here in orange. So I'm going to plug in -3 and maybe -4. All right, then my function says that whatever I plug in, I have to square it. So once I square it, I'll get an output of 4, 9, and then this one's actually off the graph. So I'll plot what I can. So -2 comma 4 and -3 comma 9. And again, this is the parabola that looks just like this. And it's only a part of it, right? So the parabola goes like this. But we only want the piece of it to the left and including -2, right there. All right, then let's take a look at the pink part of the function, the middle part, that is between -2 and 2, but not including those values. So let's graph that. So even though I shouldn't plug in -2, I want to see where our graph would end up, just so I can know like where it ends. So I'm technically going to plug in -2 here, just bear with me. It's not going to be an actual point on the graph, but we're just going to get really close to that point. So I'm kind of breaking a math rule here by plugging in -2, but I just want to see where it would end up. All right, 3 minus -2 is 5. So I'm actually going to have a hole at the coordinate point -2, 5. Because our graph will get close to there. So that's not a very good. Let's try that one more time. Oops. Okay, something like that at -2, 5. All right, then I'm going to plug in another point. So I'm going to put like a little dots around this. All right, then I'll plug in -1, 0, and 1. And then I'll plug in 2 using kind of that same idea. All right, let's plug in -1. 3 minus -1 is 4. 3 minus 0 is 3. 3 minus 1 is 2. So this is just a line. So -1, 4 is here. 0, 3 is here. And 1, 2 is here. And then if I plugged in 2, I would get 1. So 2, 1 would be like an open circle there. So we're not including those. So that's just a line. And that makes sense. It has a slope of -1. So it's going down. And has a y-intercept of 3. Okay, lastly, this is the function f of x equals 4. It's y equals 4. That is a horizontal line. So no matter what x we plug in, the outcome's always 4. So I'm going to start at 2. We'll have the coordinate point 2, 4. And all to the right of 2, I just make a horizontal line, and it goes on infinitely to the right. So that is our piecewise function, color-coded. And yeah, it's not too bad. Really, the main idea is understanding what graphs look like. You know, this is a horizontal line, this is linear, and this is quadratic, so it's parabolic shaped. This is the end of our quiz review. Thanks for watching if you did. If I didn't cover one of the problems that you wanted to see, hopefully those worked out solutions helped you because they were all the more difficult ones of each type of problem. And you can always look in your book for the solutions as well. Good luck.